Okay, thanks everyone. So two major points that we had coming into this hackathon. We wanted to identify a real issue. And in our case, if you look at the two videos here on the top right, we have typical practices for marking paint on the road. Now, the issues we've identified is firstly the chemical hazard to the operators, and secondly, we have the hazard from the unpredictable road flow and traffic. Our conceptual solution for the hackathon was basically to develop an automated method for applying these road markings. So, firstly, on a broad concept, we wanted to retrofit the wheeled robot, which I'm sure all of you saw, so that this can actually apply the road markings instead of the human being. So on the right here, you see some early concept drawings that we came up with the robot and the extension of the arm that sprays the paint onto the road, and also the infill patterns for how the paint is actually going to be applied according to which logic as well. So the requirements. What we wanted to do is we wanted to look at the pathfinding logic, the paintwork in Dynamo. We wanted to enable the robot to be able to actually interpret the output that we have from Dynamo. And finally, we wanted to be able to retrofit this painting assembly onto the robot, which started off quite basic from scratch. And finally, the constraint is to complete this all within 18 hours. So coming into this, we just had the robot, we had the 3D printer, but nothing else was prepared. Okay. Perhaps maybe Jan, say something about what we're looking at here in the video.
This short video shows the general idea of the path generation in Dynamo. So it works with different geometries, and you can see there is a meandering pattern which does the paint at the end. So just a very general strategy.
So as I'm sure all of you saw our 3D printer here, so there's a nice photo of it working in action. In this view, we see how we're actually designing the parts. So these are the small kind of assemblies that we're using to attach the paintwork onto the paint assembly onto the robot. Here we have a short video of it actually working in action. So I believe, Nico, this part was to hold the paint canister, I think, was it? Or? Yeah, okay. So this part was kind of like a hook to hold the vertical, it's kind of like a ketchup bottle, to hold it in place, while it's actually spraying paint downwards. So again, we have these three components that you see here are all kind of made yesterday and today, and they're forming part of the assembly that's holding the retrofitted parts together. In this video, so upside down, but you can see, Jan say?
Yeah, these are two peristaltic pumps we constructed or we modified. They're used for the pumping of the liquid of the paint. It was quite difficult to synchronize them, and they were pulsing, so we tried to modify these pumps so that they're not pulsing anymore and a continuous flow is generated.
Yep, here we have a video of the robot actually working in action. This is before we had some technical glitches, so it's great that I took a video then. As you can see, so we have the robot is the core component we started with. All the assembly above is what we actually used we designed and printed through the 3D printer. And as you can see, our beautiful little spray bottle up there, which was made from sugar and water. That was my design. Finally, that's it.
So in general, a hackathon can be hardware hacking too. This was our main idea.
What I want to reiterate as well is we really wanted to identify something that we thought was kind of a real solution, real problem in the industry that kind of also includes elements of construction, BIM, also robotics. We thought this was important, and we also thought, okay, the solution needs to be somewhat realistic as well. So it's not just a concept that may be implemented in 5 years. We truly think that there's something that we could actually kind of make into a more robust concept and actually use. So
final conclusion is we need more time. We bought some light equipment and ultrasonic equipment and so on for the navigation, but there was no time to implement anything of that. Okay, thank you very much.
Thanks.